Welcome to SciWave, your weekly science update. Zombie star's magnetic personality reveals connection to cosmic magnetars. Magnetars are incredibly magnetic dead stars, which have perplexed scientists due to their powerful magnetic fields. Despite being widespread in our galaxy, their formation remains a mystery. A recent research has identified a living star with the potential to transform into a magnetar. The star is called HD 45166 or zombie star. It is located 3,000 light-years away in the constellation Monoceros and had long puzzled scientists due to its unconventional behavior and unique properties. A study led by astronomer Thomas Schenner from the University of Amsterdam sheds light on the star's nature and its connection to magnetars. The star is part of a binary system, rich in helium, and has a mass few times greater than that of our Sun. The breakthrough in understanding HD 45166 came when Schenner and his team hypothesized that the star's behavior could be influenced by a strong magnetic field. The team used various telescopes around the world to study the star's properties. The observations confirmed the team's suspicion that HD 45166 was indeed magnetic. It possesses an exceptionally strong magnetic field of 43,000 Gauss, which makes it the most magnetic, massive helium star known. The team's calculations indicate that HD 45166 will eventually evolve into a magnetar. As the star collapses under its own gravity, its magnetic field will intensify, and it will transform into a compact core with a magnetic field around 100 trillion Gauss, which makes it the strongest known type of magnet in the universe. The research also provided insight into HD 45166's mass and its binary system arrangement. Its mass is smaller than previously thought, which is around twice the mass of the Sun, and there is a larger separation between the two stars than previously believed. The study also suggests that HD 45166 likely formed through the merger of two smaller helium-rich stars. This study not only introduces a new type of massive magnetic helium star, but also contributes to our understanding of the formation and evolution of magnetars. And here's the next news. A new study reveals a link between gray matter volume in frontal region of the brain and adolescent smoking initiation and nicotine addiction. Nicotine intake, primarily through cigarette smoking, is the most widespread addictive behavior worldwide. Smoking initiation most likely occurs during adolescence, and according to some previous researches, exposure to nicotine in early adolescence could increase the chances of developing a future dependency on nicotine. Let's see what an adolescent's brain goes through during and after the initiation of substance use and addiction. The transition from adolescence into adulthood involves significant brain development. The brain becomes better at cognitive control, thus improving adaptive behavior such as risky decision-making and conduct control. Its disrupted development has been linked to maladaptive behaviors like addiction. Additionally, substance use, including exposure to nicotine, could harm the brain and accelerate its aging process. Conducted by a team led by researchers from the Universities of Cambridge and Warwick in UK, along with Fudan University in China, the study analyzed brain imaging and behavior data from over 800 young individuals aged 14, 19, and 23. Who were smokers or non-smokers. The findings revealed that adolescents who initiated smoking by age 14 exhibited lower levels of gray matter in a section of the left frontal lobe associated with decision-making and rule-breaking behaviors. The researchers also noted a decrease in gray matter in the right portion of the same brain region among smokers. And importantly, the loss of gray matter in the right prefrontal cortex accelerated only after smoking initiation and is associated with sensation-seeking behavior. The researchers also used 2 questionnaires to study participants' personality traits related to seeking novelty and seeking sensations. The novelty-seeking questionnaire focused on rule-breaking behaviors, while sensation-seeking looked at pleasurable experiences. Having less gray matter in the left prefrontal cortex was linked to seeking novelty, while lower gray matter volume in the right prefrontal cortex was associated with seeking sensations. So, watch out, smokers! Your prefrontal cortex might just be throwing a sensation-seeking party that's getting a bit out of hand. The study suggests that potential treatments for addiction could be psychotropic drugs or therapies that preserve gray matter volume in the right prefrontal cortex or enhance its functions. Zinc-Air batteries spark a sustainable energy revolution for powering electric vehicles. Edith Cowan University's recent study highlights Zinc-Air batteries as a promising replacement for lithium-ion batteries, addressing issues like cost, limited resources, and safety concerns. Led by Dr. Mohammad Rizwan Azhar, the research underscores the appeal of rechargeable Zinc-Air batteries due to their affordability, eco-friendliness, high energy density, and safety features. This development is particularly timely with the rise of advanced electric vehicles and aircraft, spurring the demand for more efficient and cost-effective battery systems that outperform traditional lithium-ion options. Zinc-Air batteries consist of a zinc-negative electrode and an air-positive electrode. Historically, their drawback has been low power output due to poor air electrode performance and short lifespan. However, this new breakthrough involves using new materials, including carbon and affordable iron and cobalt-based minerals, to reconfigure these batteries. The innovation significantly reduces internal resistance, leading to high peak power density and extended stability. Dr. Azhar highlighted the limitations of intermittent renewable sources like solar, wind, and hydro energy in ensuring reliable green energy. He pointed out that the abundance of zinc in countries like Australia and the widespread availability of air makes Zinc-Air batteries an extremely feasible and dependable energy storage solution. Edith Cowan University's Zinc-Air battery design is a significant step towards Australia's alignment with the UN's Sustainable Development Goals and the objectives outlined in the 2015 Paris Agreement. This reconfiguration reinforces the pursuit of sustainable energy resources to combat climate change. So, as we bid farewell to the woes of finicky air electrodes and the tyranny of limited lifespan, let's raise a toast to Zinc-Air batteries, the unsung heroes of the electrifying energy evolution, powering us toward a greener, zippier future with more volts and fewer jolts. And these were the top science news of the last week. Thanks for watching. Stay curious, stay updated.